Gonna put the world away for a minute, pretend I don't live in it. Sunshine gonna wash my blues away. Had sweet love, but I lost it. She got too close, so I fought it. Now I'm lost in the world, trying to find me a better way.
Hey, welcome back everyone. Today's objectives are to identify, name, and draw molecules that contain the carboxylic acid functional group, recognize and predict products for reactions that carboxylic acid molecules will undergo.
Okay, so let's start off with what a carboxylic acid exactly is, the general formula. You can see below, of course, the R group, just like always, represents any group of carbon chains. Could be 1 carbon, could be 10, and anything in between. To be a carboxylic acid, on the end carbon only, this has to be the one of the end carbons, you have a double bonded oxygen here, and an OH group here, coming off the exact same carbon. This group, whenever you see it, is called a carboxyl group and can only exist on the end of a carbon chain.
Let's go over some naming rules for the carboxylic acid. First, we're going to find the longest carbon chain with the carboxyl group attached. Name as the parent chain with the oic acid as a suffix or ending. Then we're going to number the chain starting at the end with the carboxylic acid, or the carboxyl group. We do not need to include that number in the name because it automatically comes off the first carbon. And then we're going to assign names and numbers to any of the attached groups and arrange the name as always. So we have a methyl coming off the 4th carbon, so it's 4-methyl hexanoic acid.
Here's a slightly more complicated example. If you look at the molecule below, you might notice that there are 2 carboxyl groups, 1 on each end. 2 is, by the way, the most you can ever have, just because there's 2 ends on every carbon chain, so you can have 2 carboxylic acids. If there are 2 carboxyl groups, 1 on each end, we have to use the suffix dioic acid instead of just oic acid to indicate that there's 2. All the other rules are pretty much the same though, so our backbone here is 6 carbons long, making it hexane dioic acid. Notice we do not need a number to say where those carboxyl groups are. You want a number to give the attached groups the lowest set of numbers possible. For this molecule, that would be starting on the left. Those are both methyl groups, so putting the final name together, we have 2,4-dimethyl hexane dioic acid.
Alright, now we have a carboxylic acid that has a double bond on the main chain, so we're going to do the same thing here. We're going to find the longest chain starting with the carboxylic acid. Then we are going to number the double bond and give it the 2 showing where the double bond is. So it's a 2-butanoic acid. After that, we're going to do the same thing by just identifying any substituents coming off of there. So we have a 2-methyl 2-butanoic acid.
Alright, so now let's try an example with a carboxyl group attached to a cyclic alkane. If you see this, if a carboxyl group is attached to the cyclic alkane, simply use cyclo as a prefix like we always do, and you give the carbon with the carboxyl number 1. Now when we say the carbon with the carboxyl, we don't mean this one. This carbon is considered part of the group itself and does not need a number. This carbon right here is the carbon that receives the number 1, so let's find the backbone. Cyclopentanoic acid, because there's 5 carbons in a ring. The numbers have to start at the carbon with the carboxyl attached. You just have to choose clockwise or counterclockwise to give them the lowest numbers. That would be clockwise in this case. Your bromo then gets the number 3, final name being 3-bromo cyclopentanoic acid.
It's special benzene naming time. Take a look at our benzene over here with our carboxylic acid, and then we have one other functional group. There's substituent attached to it. Therefore, it's di-substituted. We're going to follow all the same rules that we are used to. This is going to be benzoic acid. The carboxyl group gets the number 1, and then from there we could assign numbers to the lowest. But because this is di-substituted, we are going to use OM or P. In this case, we're in the M position. And we have a methyl group coming off of the M position, so this is going to be M-methyl benzoic acid.
Now for some examples of reactions that carboxylic acids undergo. We'll start with what we're going to call the acidic reaction. Carboxylic acids, of course, are acids. That's why that word is in the name. And they react as acids when you mix them with water, like all acids do, by losing an H+ ion. So the hydrogen from the OH in the carboxyl is going to move over to the water. Your products are the same carboxylic acid except with the hydrogen missing, and it technically has a -1 charge on that oxygen now. The H2O, of course, turns into H3O, and that has a +1 charge.
Alright, we introduced this reaction in our previous video on aldehydes, but we're going to bring it in again for carboxylic acid since it uses both. We go from an aldehyde to a carboxylic acid. So here we have our main chain with an aldehyde attached to it. We have an oxidizing agent, and all that's going to do is it's going to add a hydroxyl onto this aldehyde, making it a carboxylic acid.
And finally, just some common carboxylic acids that you might recognize from your everyday life. The well-known sour flavor of citrus fruits is due to citric acid, this molecule down here. It's a 3-carbon chain that contains 3 separate carboxyl groups. We also have the less common example of oxalic acid, which is in rhubarb. Rhubarb has a really sour taste, especially before you cook it. Oxalic acid contains 2 separate carboxyl groups. We would call this ethane dioic acid if you were using the official naming rules. And lastly is lactic acid, the molecule you see below. If you've ever felt a stinging pain in your muscles from overexertion, the sting you're feeling is because your body is producing lactic acid in the muscles.
Well, that pretty much wraps up today's lesson. Our objectives were accomplished. We identified, named, and drew some molecules that contain the carboxylic acid functional group. And we also looked at a couple reactions that a carboxylic acid molecule will undergo. If you have any questions, please bring them to next class.